होता है किसी भी बल्लेबाज के लिए। जैसे इनिंग की शुरुआत में आपने कहा वो बैकफुट पे खेले जरूर स्पिन के खिलाफ, मगर अब वो ज्यादा फ्रंट फुट पे भी खेल रहे हैं।
Kindly please make your mic in mute, please. Karthik and Kunal.
Hello. Hi.
Karthik, are you Tamil or
Tamil, ma'am.
இந்த மைக் கொஞ்சம் ஆஃப் பண்ண முடியுமா? நான் ரிப்பீட்டட்லி உங்களோட மைக் ஆஃப் பண்ணிட்டே இருக்கீங்க. நீங்க அது திரும்ப அது ஆன் பண்ணிட்டே இருக்கீங்க. ப்ளீஸ் அது மியூட்ல போடுங்க. கிளாஸ் ஸ்டார்ட் பண்ணதுக்கு அப்புறம் ஏதாவது டவுட்ஸ் இருந்தா மட்டும் அதை டர்ன் ஆன் பண்ணுங்க, மைக் மட்டும். Good evening, ma'am. We can start the session within 2 minutes. We can start the session.
Yeah, okay.
We can start the session, ma'am.
Okay, Adira. Can you see my screen? Adira, can you see my screen?
Yes, ma'am. Yes, ma'am.
Good evening, all. I'm Dr. Prasanalakshmi from King Khalid University in Saudi Arabia. I work here in Abba branch, and today we are about to see a topic on general discussion with introduction to Internet of Things. So, regarding Internet of Things, I think you might have come across so many terms and terminologies what we use in Internet of Things. So here we will be discussing just the basics of what is Internet of Things and how it is used in different domains in nowadays, and most of the applications where we use on a day to day basis, like even a fit band, a watch, or whatever it is, a mobile application, whatever it is, everything comes under what we call as IoT. So uh, just give me a second. Yeah. So now we will look on to the topics what we are going to discuss today. So first, in general, what is IoT? IoT is what we call as Internet of Things. Things is everything, whatever we see, whatever we want to make it as a smart, it is things. Whatever we want to make it as a smart device, we call it as just in general as thing. Internet of Thing is all these devices are altogether connected through internet. Why are they connected to internet? All these devices are to be connected through some protocols of Wi-Fi or whatever protocol we use. Through some means of protocol, it is getting connected. For example, if we want to use share file between one mobile to another application, one another mobile to just to share a file, or we use in Apple mobiles, we use it in Android mobile, so many items, whatever we use, whatever devices we use, we are just trying to share something from one device to another device without physical connectivity. So for this connectivity of virtual nature, which is not going to be physical, we will be using some protocols which are meant for communication. In general, in all our mobiles, laptops, PCs, we use Wi-Fi. So that is the major source what we generally use as a public. But apart from this, there are so many communication protocols which are used to communicate from one device to another device, which is spread world over. For example, if you have a hospital, I have my mobile with me at home, somewhere, some kilometers apart from the hospital. Even then, I can monitor a patient's data. A doctor can monitor a patient's data in his mobile once when it is getting configured together. So this connectivity is through some means of communication protocols. So here, what we mean as IoT is it is a physical object. It is what we call as the physical object, device, and systems that are connected to the internet. So all these devices together, we call them whatever comes under the connection, we call them as smart devices. Smart devices, as the name says, they act very smartly. So using how are these smart devices getting activated? How are they connected together? by means of sensors, softwares, and some connectivity to collect the data and send or receive the data. So this is an interconnected ecosystem. As you see in this diagram, you can see a lot of things are happening. Like a bus is getting connected, a signal is getting connected, mobiles are getting connected. So many platforms which are getting connected together are meant to be as smart devices. Each and every device which is under the network is said to be a smart device. So by sharing this data, the IoT will allow you to make on with automation. What is this automation? Something which is done automatically based on some data or some value or some command. For example, you would have seen driverless cars. These driverless cars are automated, so they work automatically based on if any other vehicle is coming in front of them, or if it is about to be like some other cars are which are coming nearby, or some pedestrians are crossing the road. All these are getting signals from these people from the surrounding environment, and it gets automated automatically. That is what we call as automation. So whatever we do as automation process will come under IoT. Or for remote monitoring, as I told, a doctor can view the patient's detail in his mobile, which is who is there in an ICU. If a patient is there in ICU, who is connected to a smart device or an IoT device, he will be monitoring the doctor will be continuously monitoring the patient, even if he is so many kilometers far apart from the hospital. So that is what we call as a remote monitoring. And we have seen so many webcams. We can use surveillance systems, CCTV surveillance systems. Suppose if I want to monitor my house at India, I can monitor from here. It is a smart device. It is an IoT device which is connected through some communication channels, where every movement on the camera can be seen from here, which is so many miles apart from my home country. So these are possible by means of IoT. So this is what we call as IoT. This is the general aspect what we saw as IoT. So what are the key features of IoT? What we need for IoT? We need a device and a sensor. So as we know, devices, as I told you, if I have a CCTV, it is a device. If I have a motion sensor in the CCTV, it is a sensor. So sensor and devices will be both altogether same. For example, if I have installed a CCTV with a motion sensor at my home country, and if I want, I cannot keep on monitoring my home all the time, 24 hours in my mobile. So what I will do is, once when the sensor triggers that something is moving in front of the camera, CCTV, immediately it gives me a alarm or a signal or a notification that something is moving over there, so that immediately I can watch it. So these sensors and devices are integrated one, which can be any type of sensor. It can be like a temperature, humidity sensor, which is used in agriculture, motion sensor, which is used for surveillance, light sensor, which is used even in surveillance. So all these are what we say as physical entities. These sensors and devices are physical entities. We can see it. But when we come to the second feature, which we call as connectivity, as I told you, what we generally use is Wi-Fi, Bluetooth. Apart from this, we have some other high-end networks, which we call as communication protocols, Zigbee and cellular networks, which is not under our control. Wi-Fi and Bluetooth, even if you try to communicate with the longer people, you cannot communicate. But with cellular networks and Zigbee, you can communicate with the distant people also. So that is the connectivity which is not physical. It is not physical, it is just virtual. We can just imagine that yes, some connection happens there. My mobile is getting connected to a cell phone tower, cellular tower, but I cannot see the connectivity. There is a connectivity, that's it. So that is what we call this as a virtual variable. The third feature what we have is the data exchange and processing. So why to connect? Why to connect these devices? I have several devices. I have several units in my smart home. So I need to get them connected. Why should I get them connected? To take up the data, to either to receive the data or to send the data. For example, if you have a smart home, You can switch on your air condition before you reach home. Maybe 10 minutes before you reach home, you can switch on your air condition through a IoT device. So this is for data exchange and processing. So this three constitutes the IoT. This is what we call as the components of IoT or the features of IoT: sensors and devices, connectivity, data exchange, and processing. Some of the examples what we have in real time now. One is smart home devices, wearables, industrial sensors. So wearables, we know to check the sleep patterns, at what time we should sleep. We sit for a long period of time, it gives us an alarm that you're sitting for a long period of time. Have a physical activity to track your heart rate, to check your blood pressure, your fitness trackers. All these comes under wearables, whatever we wear, a human wears to get a track. Maybe like we have a glucose monitor now to check if it is going to be a very serious patient who needs to have a control on the glucose level very often. They get this device, like just like a watch or any wearable. They used to wear it, and once when the glucose level goes up to some point, it will not give any alarm, but when it reaches some range, it gives an alarm or a notification to the mobile or to the nearby people, like their relatives or well-known people, to take care of the particular patient. The second one, what we would have known as smart home devices like Alexa, Google Assistant, CCTV cameras. All smart home is something where everything is equipped with IoT. Next is industrial sensor. Where do we go with this industrial sensor? Right from ordering the raw material, purchasing it, tracking the inventory, processing the manufacturing, and sending it back on track. That is towards the delivery process. Everything is monitored by sensors. So there comes industrial sensor. So these are very few examples where IoT is being used. So how this IoT works? As I told you before, it needs sensors and devices. So whatever device we use, it has a sensor with it. If we have a Fitbit or a Fit tracker with you, this Fit tracker will track your blood pressure or your pulse rate, everything using a sensor. So the device what is getting connected is your watch. So this is sensor and devices. So a device cannot work without a sensor. It needs obviously connectivity, as I told you, general connectivity, what we use is Wi-Fi, Bluetooth, all these. Apart from that, we have cellular networks and Zigbee also. And there comes a new term which we call as cloud computing. So whatever we communicate, wherever we communicate, everything is stored in some place. It should be stored in some place. See, for example, you can take your track of your steps every day, how many steps you're walking every day using a Fitbit or any other smartwatch which we use. All these data are stored in a place. For now, we call it as a place. It is stored in some place. It is not stored in your device. It's stored in your place. Because your watch cannot store, it cannot have such a lot of memory to hold all the data every day for the complete year. So everything is stored in a place. So what is that place called as? It is a cloud. It is not actually a physical entity. It is a virtual entity which we call as a cloud. So all the data, whatever we get transacted through the IoT devices, everything will be stored in a cloud only. So what happens there in the cloud? Just a storage part and some communications, like some processing data will be there, that we will see in the next forthcoming slides. Finally, we have the user interface, where we can see that is in your mobile. You can just open an application like a health application, and you can see how many steps you have walked, what is your intake of water, uh, what is your physical activity this day, this week, or this month. So, how is your health condition? So, all these can be tracked through a just an application. So, that application is what we call as user interface. Generally, user interfaces are dashboards. Okay. Okay. Till now, it is fine. Shall I move on to the next topic to get into detail
Fine, ma'am.
on?
Just is it
Yeah,
audible?
yes.
Just a minute. Can you you are presenting the screen?
I couldn't get you.
No, you presenting the screen actually. Anything you told that slide or just something presenting. I couldn't able to see the screen. That's why you are presenting the screen.
You cannot see the slides.
Yes, ma'am, we can't see because I have
No.
already messaged you in the chat, but you
Oh,
didn't
sorry.
see the message.
I didn't see it. I asked you before is it shared? You said yes.
Yes, ma'am. Initially it was visible, and after you turned off the video, it got stopped.
Now is it fine?
Yes, ma'am, it's visible.
Yes, now it's
Okay.
fine. Okay, fine.
So just let me show up the slides. That's it. So this is what an IoT looks like. It is connected to the smart devices. So as you can see in this diagram, you can see so many devices which are getting connected, which we call as the IoT device. So the next one, the key features what we have is the sensor and devices, then connectivity, data exchange and processing. So sensors and devices are, as I told you, everything will be embedded. Your sensors will be embedded with the device. So unless you have a sensor embedded with a device like a CCTV embedded with a motion sensor, it is of no use. You can just see all the 24 hours you need to watch on it. Just to get an attention on a notification, you need a sensor. Then the connectivity, as I told you, it is going to be Wi-Fi, Bluetooth, Zigbee, all type of connectivity can be there. And these are the examples what I told you, which is going to be wearables, smart home devices, industrial sensors, all these. And I think that this is what I have discussed till now. Shall I move on to the technical part little? Is there
Yes,
any
ma'am.
question to this? Shall I move on to the technical part of it?
Yes.
Yeah. So the first, in the forthcoming 3 to 4 slides, you will be discussing about these 4 components: sensors and devices, connectivity, cloud computing, and user interface. So here the sensors and devices, why are they used? Just to collect the information, collect the data from the environment. So what does this data means? Something which is in numbers or which is in images, some information which will give you some impact is what we call as data. So it depends. Is if we have a CCTV camera, it is a video or frames of videos. That is an images. So that is what we call the data there, which is a unstructured data. It is not a structured data. It is an unstructured data. When you go with data related to collecting the temperature, moisture of your place, concerned place, then we can call the data structured data, which is going to be in an Excel format or in a tabular format, which is structured already. So it can be of any type of data which you're going to collect. So IoT devices supports any type of data. So it is going to be collected from your environment, from sensors and devices. So these are the one which are the one which we call as input devices. So we don't give any inputs here directly. As we know, when you are connected to a computer oriented domain, you have an input, you have a processing unit, you have an output. So the input what is received from here is sensors and devices, from the sensors and devices only. We are not going to give any manual input here. Likewise, why are these sensors used? As we know, these sensors are embedded into the objects or the machines. Like if you have a watch, you will have a sensor. If you have a mobile, it keeps tracks of your GPS, how many steps you walk, what is your physical activity, to which locations you have done. All these are the data which is getting collected. How is it collected? Based on sensor. Okay. So what are the sensors that can be used is temperature sensor. When we use a thermostat, like what we say as a air conditioner. Suppose if I want to switch on my air condition when I'm outside, I am just reaching home in another 30 minutes or 1 hour. I just want my home to be cool when I enter the room. Using an IoT, I'll be switching on the air condition. But how long will it run? Using a thermostat, it cuts off after a particular temperature is reached. It goes to sleep mode. such that no power consumption is taken. That is why we call this a smart thermostat. The smart thermostats are nothing but they give an automatic on and off based on the surrounding temperature. Similarly, when you go with agricultural sensors, it is what we call as humidity. Humidity sensors are one which measures how much humid your climate is, how much humid your environment is. So these are actually used in agricultural sensors. The next, as I told you, motion detectors or security cameras use motion or proximity sensors. These proximity sensors are the one which we use in our even in our mobiles. Accelerometer, proximity sensors, all are available in our mobiles also. So what happens with this proximity sensor is when you move, when you walk, your steps are counted. When you stay and in the same place, if you're keeping on giving an action that you're walking, it will not count. You can just check it. Proximity sensors are one which detects the motion of your current object. Okay. Similarly, when you go with light sensors, these are used in smart street lights. This smart street light application we will discuss further. Similarly, noise monitoring using a sound sensor, industrial machines monitoring using a pressure sensor. So many sensors are there. These are some examples, that's it. So each sensor has its own behavior to collect the data. The next one, what we have seen is connectivity. So after collecting the data, we need to send it or receive it. So for that, we need a connectivity. So how is this connectivity made? Using any of these protocols like Wi-Fi, Bluetooth, Zigbee, 5G, 4G, any cellular network. Then low power wide area network. It is a WAN network. So this is general network where we use it in CCTV surveillance when it is going to be on a large area. Like in my home country, I have installed a CCTV, and from here I need to watch it. I'll be using a low power wide area network with the support of cellular networks, of course, because we need a network communication between them. So cellular networks will support them to transfer the data, but the complete vision or the complete movement of my device can be seen using the wide area network. So these are some of the connectivity protocols which we generally use. The third component what we have seen is cloud computing. As I told you, cloud is a place where something is stored. This place you cannot see. It is not a room or it is not a server. It is a virtual environment where your data is getting stored. So as you know, Amazon Web Services, you would have heard about these words: Amazon Web Services, Microsoft Azure, Google Cloud, OneDrive. All these are data storage locations. So these are what we call as the cloud platforms. And apart from that, what happens there in the cloud is it doesn't only store the data. As I told you here, all your data gets collected in the IoT, and your this through the IoT devices, all your data is transmitted to your cloud. So what happens in the cloud? It is not only storing the data, but it also processes some data. Whatever you need to process, everything will be processed in the cloud only using artificial intelligence, machine learning to process these data and to find something as an output. So when you put up a large amount of data, we call it as big data. Okay, so that is why big data comes here. Big data is the one where when huge data is being monitored, we call it as big data. So this is the process of the third component of your cloud computing. And the fourth component is user interface.
Gopi, kindly keep your mic in mute. Mr. Gopi.
And the fourth component is user interface, where we will be looking into the end user interaction applications or dashboards. As I told you, in your mobiles, you can see health application, fitness application, so many applications are there. So everything is getting monitored and stored somewhere, and you can visualize today how many steps I have walked. Yesterday, what was my progress? In this complete week, what was my progress? All these comes under dashboards.
I can't help you with that.
So the next is voice assistants. Using Amazon Alexa or Google Assistant, we can go on with enabling using some voice commands. Alexa, play this song. Using this voice commands, it is working. So you need sensors, of course, for that to detect your voice. Because Alexa cannot respond to all the voices. It will respond to only the owner's voice, which is registered there. Then how IoT works in practice. For example, this is an example scenario where it is taken as a case study, where your sensors and devices are thermostat detects the current temperature in your home. Based on that, you can see the sensors and devices will detect your current temperature at home. Then this is being transmitted, this data, the data what is connected is the current temperature, which is stored to the, which is moved to the cloud using a Wi-Fi. So in cloud, what happens is, where it determines whether the temperature is too low or too high, and based on the user's preference, based on my preference, whether I need a very cold temperature or I need it to be a moderate cold, and the time of the day, whether it is daytime or nighttime or afternoon, based on it, my temperature will be decided here in the cloud computing, and your user interface will help you to change according, that is your user interface in the sense the application which you use in the smartphone, in your smartphone application, you can adjust your temperature as you wish. So this is an example of a smart home. This is an example where we call it as a smart home. There are so many devices in smart home. This is one such example. So this smart home scenario can be taken as a real-time example of a IoT device. So as we told, the key components of IoT, again recalling it: devices and sensors, connectivity, cloud and data processing. Finally, it is user interface. Coming to the technical part, what is the architecture of it? Okay, you say that your data is collected, it is put somewhere through the communication channel to the cloud, it is processed there, and your output is visible. Okay, everything is fine. But what happens actually internally? What happens? So your internal layers are divided into layers, which we call as perception layer. If you would have come across the computer networks, you would have seen so many layers, 7 layers of OSI network, ISO or OSI. So you have 7 layers there, and we have here 5 layers, which is perception layer, network layer, edge computing layer, cloud layer, and application layer. So this application layer is the one what we see in the application. Okay, so we will just leave off this. We will go to the cloud layer then. So your application layer receives input from the cloud layer. So what happens there in the cloud layer? It is storing, analyzing, and managing the data in the cloud. So when we go from where the data to cloud layer comes is from the edge computing layer. Here they are introducing a new layer which we call as edge computing layer, where your data is getting actual processed and it is sent to the cloud. Okay, your data cannot be sent as a raw data into the cloud environment, so it is getting processed and it is sent. So from where this edge computing layer receives data? From the network layer. Through the network layer, your data is sent over. So from the network layer, from where this network layer receives data? From the sensor. So that is what we call as a perception layer. So in your previous slide, we have seen 1, 2, 3, 4 components, which is device and sensor, that is perception layer. Then your connectivity, which is your network layer. Your cloud and data processing layer, together it is written here, storage and analysis. That part is edge computing and cloud layer. Then your user interface is your application layer. This is how your architecture of IoT works. So coming to layer by layer, we will see one by one, where it is your function. What is the function of a perception layer? As we told before, it is going to, perception is nothing but sensors and actuators. So based on your sensors and devices, only your perception layer will start working. Once when your sensor gets triggered, your perception layer starts working. So the perception layer is the one, a physical quantity, physical entity, that is your mobile or your watch or your CCTV or whatever device we have as physical component is the constituent of your perception layer. So from there, sensors and actuators, these both play a role there. What is the sensor? We told already, something which senses, whether it is going to sense your temperature, or it is going to sense your pressure, or it is going to sense your motion, or is it going to sense your location? Whatever it is called as a sensor. So based on this sensor, your actuator will start working. What is this actuator? If we know about something about the car driving, we have an accelerator there, where the accelerator is the major part which enables you to move the car. Even if you put your car on in an on state, your car is not going to move. It needs something to either to put up move up the gear, or to release your brake, or to push your accelerator. Any of your action is needed to push your car. So such action which is taken from the sensor is done by the actuator. So the actuator decides something what should be done based on your sensor. Okay. For example, if you're having a light sensor, the light sensor will sense whether the light is off. If it is off, your actuator will on it. So that is what is actually happening between the sensor and actuator. So when this sensor and actuator comes into the scenario, here comes the actual part of what we call in today's trend as artificial intelligence. So artificial intelligence, everything works based on sensor and actuators. Something like a robo, a cleaning robo, or whatever it is. Whichever uses a sensor, there will be definitely an actuator. So when sensors and actuators play a role, AI will come inside. So AI starts from here. The next layer is your network layer. As we told before, your network layer is the one which is responsible to transmit your data using some communication protocol like Wi-Fi, Bluetooth, 5G, Zigbee, all these. So some example is you can send the temperature data to the cold via a cloud via a Wi-Fi, and you can track your fitness tracker which tracks your application. We will feel that we are keeping on speaking the repeated things, or we are repeating the same thing again and again. It is not like that. The one which we saw before is a colloquial communication to just say what is an IoT, what happens in an IoT. It was just having 4 layers. But this is the technical part where 5 layers are used, and this technical layers are the one which actual components of an IoT network works, IoT architecture works on. Okay. Next comes the edge computing layer. Here, as we told, your edge computing and cloud computing. I told you here that your edge computing and your cloud computing layer together forms this cloud and data processing. So when you come to the edge computing layer, all your data gets processed over here. Maybe if it is going to be unstructured data or a structured data, all your raw data are getting processed over here, and it is moved to the and it is prepared to move to the cloud. Okay. A smart camera in a security system might use edge computing to analyze the motion locally, and finally the shot will be sent to the cloud. So cloud will not be updated, will not get updated every time. Instead, your cloud will get updated with the data once when the motion is detected by the sensor in the local platform. So from the local platform only, the screenshot or a snapshot of the moving person will be sent to the cloud for further processing. So next comes the cloud layer, where your data is getting actually stored. So before storing these data, it computes how much space it needs to be stored, whether it is possible to store it in this virtual system or in some other virtual system. Any device, whatever we use, like Amazon Web Service or Azure or cloud, Google Cloud, OneDrive, everything is a cloud. It's a cloud. We don't have a specific server for Amazon Web Services. It is present in this location, you cannot say. It is spread over throughout the servers, and in any server it can be stored. Okay, that is what we call as virtual. So this environment will process your data, will analyze your data based on machine learning algorithms, which is already defined. If a company is going to produce, for example, if Huawei is producing a health tracker, they have their own inbuilt machine learning algorithms or deep learning algorithms to work on it. Every company has its own terminology and own secrets to do something. So one company is not going to use the same machine learning algorithm as others, as we know before. This is a competitive world, competitive business. So everyone needs to give a data with perfect accuracy. So this perfect accuracy comes with the deviation in the machine learning algorithms. So this cloud layer is the one which is going to store the data after it is getting processed in the edge computing layer. In your edge computing layer, all your data will be processed and then it will be stored to your cloud layer. Finally comes your application layer where we are able to see something. We will not know what happens actually inside. What was the communication between my Fitbit and my mobile? But something happened. My data is taken from my Fitbit device and it is stored in and it is showing in my mobile. So my mobile application will show me what actually happened, what was my previous readings and what is my current reading, what was in the previous year. All these are seen in the form of pictorial representations of dashboards. So coming to the application part of IoT, I have just shown you all the basic details of the architecture of IoT, what we need, what is the most important thing we need to know is done. So coming to the application part where getting used, we will discuss about some 5 applications. The first application is smart home. So as we know, you can see so many devices are connected in IoT, right? Your sensor here, you have a sensor here, you have a sensor here. So all these sensors are connected to my application, which is in my mobile, right? So there are so many existing smart home devices like smart thermostats to monitor the temperature of my room or my home. Smart security systems to give a door lock or to unlock a door or to give a surveillance. All these comes under the smart security systems. Smart lightning. Once when I am getting in or by some time, maybe like 6 p.m. I need to lit on the light, and by 9 p.m. I need to switch off the light. So this is smart lightning system, which is powered by Philips Hue. And what are the features I have? It is automated. Everything just with the remote or with my mobile, I can automate anything, whatever I want. Just when I enter the room, my lights should switch on automatically. I need not go to the switchboard to switch it on. It is done automatically. Security for cameras, doorbells, alarms. There comes the security systems when it is going to be a smart home. And it is, of course, more convenience. Just with the voice command, I can, or with an application, I can control all the devices, whatever I have. So obviously, these are making us a little bit lazy. But anyways, we have to go by the upcoming technology. So this is the key features what we use in smart homes. Some examples, smart thermostats, where you can monitor your temperature so that you can control your air condition or your cooler or whatever it is, so that your energy consumption, that is your electricity consumption, will be very less. Since it is needed, it is getting switched on. If it is not needed, it is getting switched off. So your electricity bills will be obviously reduced. It is optimized. Coming to the security systems, we have so many locking systems in the door, or we can monitor the home with some sort of small cameras, so motion detectors. All these comes under smart security systems. Coming to Philips Hue, this is a smart lighting system where you can dim your light, you can change the colors of your light. When you're entering the room, it can switch it on. When you're coming out of the room, it can switch it off automatically. All these comes under smart lighting system. So what are the benefits? We have energy efficiency. We can reduce our bills. It has a good security, of course. Even if no one is there at the gate to check who is coming in, who is going out, it can automatically check everything and it can send you notifications whenever needed. So obviously it is more convenient and makes us lazy. The second application what we're going to see is healthcare. So this whatever applications we use generally is Fitbit, Apple Watch, smart insulin pens. All these are some of the applications of healthcare devices. So when you go with the remote patient monitoring, we have the heart rate, blood pressure, glucose levels, oxygen saturation, all these monitored on in your hand with your device, with a mobile. Similarly, wearable health trackers, as I told you, what is your sleeping time, what is your heart rate, what is your blood pressure, what is your water intake, what is your number of steps you walk, all these are tracked by the wearable health trackers. Next comes the real-time diagnostics, where your ECG, if everyone knows about it, ECG is something which is related to the cardiogram, related to your pulse rate and heart rate. So this is automatically connected through your real-time diagnostics and even your glucose monitors, as I told you before. So these are some of the examples what we have seen. You can see the smart insulin pens when you just trigger it out to check the blood sugar level. It will get automated in your mobile application automatically. So what happens there? What is the benefit? Today, if I'm taking a sugar diabetes reading, I may forget it. But this keeps track on my insulin level continuously and says if there is something dangerous or something needs an attention, it informs us that continuously your insulin level is getting low, contact a doctor or something, some suggestion, some person to monitor us. Instead of a person, we are using a device. So these are some of the examples of IoT in healthcare unit. And what are the benefits? Obviously, we can monitor the patients even if we are not there. Some, if it is affected with some chronic disease like heart patients or diabetes, they of course need an attention 24 hours by 7. So there comes an improved patient outcome. Then personalized care. I can give a personalized care for each and every patient as a doctor, and doctor can give a care for each and every patient. How many minutes once his pulse rate should be checked, or how many days once his diabetes should be checked. All this will comes under personalized care. So obviously it is cost saving also. Instead of going on visiting a hospital frequently, I can take care of myself. I can take a personal opinion that yes, I'm doing good. I need not visit a hospital this month or next month. Or for another 6 months, I am okay with the healthcare device what I'm using. But the challenges comes there. Even if we have benefits also, there are some challenges where your data security is a concern, because in most of the countries like US, the data of a patient is very secure. No one will provide data for anything if it is going to be a medical one. Even in Saudi Arabia, there is no such concern that you can take a data from any of the hospitals for any reasons. Unless it is approved by the Ministry of Health, it is not provided. So the data of a patient, the security comes there. Is it secure or the privacy of data is maintained? So this is a major challenge over there. The second one is interoperability between devices, because medical equipments are not going to work on a same basis. If you take a CCTV surveillance camera, even if it is going to be of different brands, I can connect them because everything works on same principle. But medical devices are not like that. Every medical device works on different principles. So it is a bit difficult to connect all the devices which works on different platforms into one single IoT platform. So that is the second challenge what we have. Obviously, as I told you before, accuracy of a data is more important when you consider with when you compare with other domains. Accuracy of data is more important in medical domain, because even if your insulin levels goes little bit low or little bit high than the recommended level, the life is going to be on a tragedy. So accuracy is more important there. And obviously, as I told you here, whenever security concern comes there, privacy concern will also come there. Privacy is something where, yes, I am okay to give the data, but my name should not be shown, my age should not be shown, or my gender should not be shown. All these comes under privacy concerns. The third application, what we will see is industrial IoT. As we know now, most of the industries where automation is made, IoTs work there. One such example is Siemens IoT and GE Predicts. So where do we use this? For predictive maintenance. We call this as predictive maintenance. Why is it? when a huge machine is going to be invested there by the owner of the company, it needs to be maintained properly on regular basis. When it needs some critical care, it will immediately inform the concerned person that it needs a maintenance immediately. Even if it is not on a due, it will inform that a maintenance should be done. So predictive maintenance is the major application of industrial IoT. Then machine to machine communication. Here, for example, let me tell you an example which you can understand better. We use poultry chickens. We get separate parts. We get whole chicken. We get just the thigh pieces. So these are communicated between machines. This machine 1 will communicate with the machine 2 that this chicken weight is this much, so the thigh portion will be here, because all chickens are not of same size. One is very small, one is very big. So where it should cut, it depends on the machine to machine communication. So if this communication is not going to work properly, the cutting of chicken will be on different portions. It will not be like a portion which is sold. Okay. So that is one such application where industrial IoT has its application. As I told you, this is what we call as the dashboard, the pictorial representation of whatever we want to see as a data can be seen as a chart or as a graph. This is what we call as the dashboard. So obviously the benefits of industrial IoT is, yes, it brings efficiency, it is cost saving, it brings more safety, and obviously whenever we need the decision to be made based on the data which we take, you can take it, you can do it easily. Here also challenges in consideration comes with data security and interoperability in the sense between machine to machine communication. This will play a major drawback in the industrial IoT. And the final challenge what we have is the high initial cost, because the first investment what they make on the implementing the industrial IoT is too high. Each and every sensor or the device or the platform, whatever we bring, it is costly. And once if it is implemented, yes, the number of people working over there can be reduced, their labor can be reduced. It is efficient in that manner, but it is too costly in the manner where it is getting implemented. The fourth application, what we see is smart city. Most of the Indian cities are becoming smart cities, using some intelligent traffic system, grid systems, and more smart parking systems, and some of the key features what we use is intelligent traffic management to manage the traffic based on the traffic in the forthcoming kilometers. It will decide whether your car should move left or right, or it should take a diversion to some other routes. This is what we call as the intelligent traffic system, which will minimize your pollution, waiting time. It will reduce your travel time. So you can efficiently plan your travel based on the intelligent traffic management system. The second feature what we have is the waste management, where your waste is getting collected by the municipality people manually. Instead of manual collection, once when the bin gets complete, it will be informing the concerned people, that is the concerned department, to take the waste out of there. And even the waste containers, the trash containers, they will have some solid data, like how many kgs of paper waste we have, how many kgs of solid waste we have. So all these are segregated in the smart waste management. Coming to smart grid, whenever we hear the word grid, it is a energy consumption problem. Like whatever we have in the street lights are lit from evening 6 p.m, morning 6 a.m. But it is not going to be a constant one. Maybe if you have a cloudy climate, even earlier by 5 p.m, it should start lighting. So these smart grids will work to manage the energy distribution and to make it proper way, such that your energy is not also wasted. So these are some of the examples what we have: the smart parking system, the sensor enabled street lights. Here you can see
Bro, class.
as the cars pass, the lights will light lit on. Once when the car moves out of the sensor, the light will go off. So unless you find a vehicle moving or a person moving, the lights will be switched off only. So it saves the energy there. And air quality monitoring, the places where there are chances of pollution, they install this air quality monitoring system to check whether your air quality is good. These are mostly monitored in India. In New Delhi, most of the places have this air quality monitoring system, and even in US, Airbnb systems are the one which is responsible for monitoring the air quality of US locations. So benefits, obviously there are benefits. It is cost saving. It improves the quality. There is sustainability. There is a public safety and everything. But even then again, the data security and privacy comes there. And initial cost of implementation is, yes, obviously high. As we see here, the smart street lights, every light pole has to be installed with a sensor, and this sensor has to be connected to an actuator, and this will be monitored every time. So obviously the initial cost is high. And as we know, the sensors and systems, if we are connecting your road system with the traffic system, the devices are different, so interoperability will be difficult. The final application what we have is the agriculture. So in agriculture, in the sense, it includes everything: farming, irrigation, livestock monitoring. So when we go with precision farming is the one where precision care, individual care is taken to the particular location based on the temperature, humidity, and all other rainfall, all these features. It will be deciding whether to water this much, what will be the level of watering, what will be the level of manuring, what will be the level of fertilizer application. All these will be decided based on the current situation, or the current environment of that particular farm. Automated irrigation system, if the moist level of the soil goes down, the sensor will give an information that it should get water irrigation there, water supplied over there. Sometimes the water level, if the moist is too high, the supply of water will be less. So this is automated irrigation system. For livestock monitoring, as we know, if we are going with cattle or breed systems, or with the chicken or poultry or whatever it is, livestock monitoring, they will be put up with a wearable device where their complete health is getting monitored, like their temperature, what is their activity level, what is their heart rate. All these things will be monitored, and it will be informed to the farmers whether the livestock what they are growing, whether if it is going to be a poultry, whether all the chickens are very good and healthy. Because as you know, if one chicken gets infected, the infection will spread to all the other chickens very fast. So immediate care should be needed from the farmer side towards the livestock. So these are the current applications what we have. John Deere, this is a tractor which we know, familiar tractor company, where they have used a smart tractor system which is used for everything: seeding, planting, harvesting, manuring, everything. And soil sensors, as you can see, they will install the soil sensor to check whether there is a moist in the soil, or it needs some other, what is the temperature, what is the pH level, what is the moist level. These data will be collected, and whether it needs irrigation or not. Similarly, drone surveillance can be used even for applying fertilizers also. They are used in fertilizing also. So these are some of the applications of agriculture, and obviously there are so many benefits where the manual labor is reduced, it is cost effective, yeah, it utilizes the resource in an optimized level. And obviously the same set of challenges also here. Initial investment is too high. There are some connectivity issues, because these connectivity issues comes by means of the network issues. because in rural areas we will not have that good connectivity. So there comes the connectivity issues where the data is not getting properly updated to the cloud-based system. Then the final application is transportation and logistics. Just to manufacture, you are sending something. Your fleet tracking is to track whether your container is moving in a right track, whether it needs some maintenance or it needs some other fuel consumption or whatever it is. Your fleet needs whatever it is. Your flight, you can say. You can say your containers which carries your goods. You can say the cars, Uber. It is a fleet tracking system. So your GPS, sensors, telematics, everything will be controlled and monitored. So these are such applications where Tesla uses autopilot for informing the driver whether for informing the car whether to move in the right or to the left or straight based on the GPS and based on the cars which is coming on which speed it is coming towards the car or if is there any other pedestrian crossing the road. All these are monitored by Tesla autopilot. So these are some of the real-time applications what we have here, and obviously the same benefits and the same challenges what we have. So energy management, as I told you before, this is generally used nowadays in homes also. To if I'm not there for more than 2 or 3 minutes, my air condition or the light will get switched off. So it is improving my energy bills. So solar panel integration, all these are applications of energy management. So with this, I'm closing the session. I think I have given applications which is related to IoT. Even if it is not so technical, I have tried my best to invoke an idea where IoTs are used. So you can imagine, just imagine that whatever you use from the day morning, the time you wake up till the time you go to bed, all the devices, whatever you use, is nowadays in under the control of IoT. Because as we know, it has come under we are under the era of artificial intelligence. As a computer science people, most of the people will know that it is under machine learning. Even not only computer science, electronics, mechanical, automobile, everywhere AI and machine learning plays a major role. So to come up to that part, we are in the era of artificial intelligence. So even if we are common people, even if we don't have a BTech or something, a general farmer, he is using a smartphone. He is using a smart mobile where everything is getting tracked. His voice, his movement, his GPS, everything is tracked by a sensor. So obviously it is also a IoT device. So with this, let me stop the session. If you have any questions, you can ask me.
Hi, madam. Can you share the slide with us after finish?
Yeah, of course.
Thank you.
Anything else if you want to ask, even apart from this topic, if you want to discuss something, you can discuss. Okay. Adira, I think I have completed my session. If there are any questions in the future also, you can just post me. I can reply to them.
Excuse me, can I ask some questions not regarding this topic, related to the exams?
Okay.
Actually,
I don't know even.
informed by the student affairs because ma'am doesn't know because she is not an
Okay.
employee of education, so she doesn't know. Kindly contact with me.
Can you reply me,
Yeah, because I
Adira?
do. Yeah, in which university you're doing? Can you? I will give you my. I think you are having my WhatsApp number. So can you kindly contact and that and me because the session is almost to wind up. So please text me after the session. I will
I don't have your WhatsApp number. I have a WhatsApp number with a Gayatri. I don't get a proper reply from her. That's why I'm asking
Shall
here.
I? Your name is Varsha, right?
Varsha. Yeah.
Okay, okay. Anyways, I'll give my WhatsApp number in the chat. You can take that and you can text me so that I will
Okay.
answer questions. Okay?
Okay. Okay.
Yes.
Yes, Adira, is there anything else? Should I reply for anything? Adira?
No, ma'am, no.
No, ma'am. Okay. Thank you all. Hope this session was useful to you. Try to see you in another session. Thank you. Thank you, Adira.
Thank you.
Thank you.